Welcome to your own channel of Right Funda. Here is another very interesting problem from rotation mechanics. You can say spiral motion of the particle. Let's read the question. What they saying? Under the action of a certain central force field, a particle of mass m undergoes motion along the curve r is equal to a theta, where a is a positive constant. The magnitude of the angular momentum of the particle about the center of the field is capital L. Question is asking, find the central force as a function of r under which such a motion is possible. Such that what should be the force field here? So the particle will move in a spiral path, and the distance the particle from the center will be changing as this function. The distance will be proportional to the angle it will be turning, a into theta. So now you have listened to the question, you understood the question, what it's saying. So you have to write everything in terms of L. Force you have to find out in terms of L. So if you wish, you can pause the video, try, solve the problem, and after some time again you can resume the video and you can see the solution. I'll be discussing the solution right now. Okay. So first see what to find out and how to find out. And this type of problem comes how to think, that we have to discuss. So we have to first find out the strategy of problem solving. So whenever some type of situation is come to us, then we'll see the how to solve the problem. Question is asking the force and what it has given the angular momentum. Angular momentum is given, one function r as a function of theta has been given, and you have to asking about the force, central force to be calculated. If you see the keyword, what is there in this question is the one field that is acting is a central field. One question, the central field is given. Central field is what? That always directed towards the center of the one particular point, or always directed towards particular fixed point. This is called central field, force field. Okay. So, and question about the force. So first I'll think from this keyword, can I get any information? Can I get any clue from this? Central force field is there. Central force field means torque about that point, particular point will be equal to 0 because it is passing through that one, or angular momentum will be conserved. The number one thing I got. Second thing is that if a central force field is there, if it is a central force field is there, then all the central forces are conservative forces. All the central forces are conservative in nature. So here a conservation of energy, total energy can be applied. Conservation of total mechanical energy can be applied. That I got, the two things I got from this information. Then say comes to the question, what is the central force to be calculated? So the conservative force field is there. First I discussed this one is a conservative force field. I can apply this one. This force can be calculated from minus del U by del R, because in case of a conservative force field, potential energy is defined, and from potential energy we can find the force. So potential energy as a function of R is equal. So how will I get the potential energy from the given question? What is given? Angular momentum is given. From that, how can I get the potential energy? First I have to think. But somehow total energy is constant. So in somehow I can get the kinetic energy, then I can get the potential energy. So my next task is to potential energy calculation that reduces to kinetic energy calculation, and kinetic energy calculation is equal to half m into v square. So I'll see what velocity the particle is traveling. What velocity particle traveling can I calculate from velocity? No, this is given only the magnitude of the position vector is given. Had the vector has been given, I could have calculated easily. But here the magnitude of the position vector given. From that differentiating, I will not get the velocity. So let's see. So our task, we got that force, potential energy will get. First we got the speed. One speed we got from kinetic energy. Kinetic energy is potential energy. Potential energy to force we can calculate. We got the strategy has been decided. Okay, let's try. Let's see whether we'll be able to solve this problem or not. So first we'll see that what is given to us is that r is given. So I can write this equal to r is equal to a theta. And if I differentiate this, dr is equal to a d theta by dt. Okay. What is dr by dt? If I try to understand what is this dr by dt there and what is d theta by dt there, you will see is that suppose I draw a circle here. Okay. Suppose in a circular path we know if particle moves in a circular path. So there is a circular path is there. Okay, but my particle is not moving in a circular path; it is moving in a spiral path. So let's cut it here. Roughly, I can draw like this. So the circular, this particle is from this position, uh, is not moving like this. Rather, it is going from here. Suppose a little bit like this. So then it will make the bigger circle. It will making a bigger circle like this. So here, if I draw the velocity vector of particle, the velocity vector particle will be like this, tangential to the path. So this velocity vector will have two components. There's a velocity vector. There's two components there. One of the component will be like this. That a circle over there, that tangential to. And another will be like this. This point. This I resolve into two component. One in the like this along the radius, and another is the perpendicular to the radius. So if I extend, this will be like this. Okay. So this is I can little bit erase this one. Not looking 90 degree. I'll make it 90 degree here. So one component like this, that where the circle would have been there, the velocity would have been like this. But as it is a spiral path there, the velocity will be like this. Okay. So this component velocity I call the tangential velocity. This I'll call the radial. This is called the radial component of velocity. Okay. What is the purpose of this velocity? The velocity is changing the position vector. But what this radial component doing? Radial component is changing the increasing the distance from the center. This radial component velocity is increasing the distance from the center. And this tangential component is responsible for this angular motion or turning of the position vector. So this and this is doing the both the things doing, and it is in fact going. So this dr by dt, it is in fact the magnitude of the position vector, this r, and this quantity will give me is only the radial component of velocity it will give. This left hand side will be the radial component velocity. So in the right hand side, what I'll do, I multiply this by r and divide this by r. Suppose this r and r are divided and multiplied. What is this r d theta? If I see this one in the circle, this was completed, then r d theta will nothing but the dl. R d theta will be equal to this dl. Okay. R d theta will be equal to dl, and dl by dt is nothing but this tangential component of velocity. So I substitute this one, then what I got is that dl by dt, and dl by dt is the nothing but the tangential component of the velocity. So I got a relation between a linear velocity, is a radial velocity, radial component of velocity, and the tangential component of velocity. I got this two relations. Okay. Now, so if I see what is given in the question, if I try to calculate that one, L is given, angular momentum, and L is equal to R cross P. R cross P. I am B. I have written this one. This is equal to L is equal to R cross P. Our L is equal to R cross MP. R cross P. Okay. So this I can write, and which velocity will be there? Because this, when you do this component R, this has two component velocity. One is the radial component velocity, V radial is there, and one is the V perpendicular is there. When you do the cross product, then this cross product will be zero. Only this dot, this tangential component will be there in the cross. After cross product will be only be present. So L is equal to M V R V T. So from this I can get the velocity of the tangential component of velocity. Tangential component of velocity I can get as this equal to L by MP. Okay. So once I get the tangential component of velocity, I can also obtain the radial component of velocity can be obtained. Why? Because this relation we have obtained. So radial component velocity can be obtained from this. Substituting this, I can get the radial component velocity to be equal to this. Okay, A by R multiplied. So I got the tangential component velocity. I got the radial component and tangential component velocity, both I obtained. So once I get both the component of velocity and the particle is going in a two-dimensional motion, I can write the kinetic energy of the particle half m into speed square. And in case of speed velocity, I'll write the radial component square plus tangential component square. So I'll be taking this one, and we know the relation between the radial component, tangential component we have calculated here. So I write the radial component in terms of tangential component. So I got this one. So I take the Vt common, I'll take, then I remain with this one. And if I take the value of Vt, what I got here, velocity tangential component L by mr, that I'll substitute here, then I got the kinetic energy of the particle as in terms of L and as a function of r, and as a function of r I obtain. Okay. So this is my kinetic energy there. And this is moving the central force field, that is conservative force field here. So total energy must be equal to constant quantity. We don't know what is the total energy given. So let's assume that total energy of the system is E naught. Let us assume that total energy system is E naught. So I get the kinetic energy plus potential energy must be equal to E naught. So from this I can calculate the value of potential energy equal to kinetic energy, is total energy, minus the kinetic energy that I obtained here. So from this I obtain an expression for the potential energy. U, so the potential U is equal to E naught into minus L square by 2m, R square I have taken inside, and I got, so this I got as the potential energy as a function of R and in terms of my L. So I got the potential energy. Once I got the potential energy, according to our strategy, we'll differentiate this one to obtain the force field. So if I differentiate both the things, then I got that minus del U by del R is equal to potential total energy constant go to differential is 0, and the second they have differentiated very easily we can do, and I can arrange this one minus del U by del R is equal to L square by m, 2 to cancel, 1 by R cube plus a square by R to the power 5. Okay, and this minus del U by del R is nothing but the force. So force will be in the direction of R cap, and the magnitude of the force that we obtain, and we can find out the value of force to be equal to this. So we calculate the force field on which it will possible, so that the particle will be moving in a spiral path, such that the R will be equal to a theta will be there, that we have calculated this one. So hope you have understood the problem, and you know how to solve this problem. This is a central force is there. This must be a conservative force field, and this you need to understand the question, and you will be solving. Then you will be able to easily solve the problem.